In this last segment, we're going to look at a very particular type of motion, and it's a type of motion we call free fall. If I take a ball and I toss it up in the air, it goes up, comes back down again, I want you to think about this. After the ball has left my hand, until it hits my hand again, during the interval of time, an instant after it leaves my hand, goes up, comes back down, till an instant before it hits my hand again, what does a graph of velocity versus time look like? We'll give you some choices. In fact, after the ball has left my hand, it's going up and coming back down again. There's one force that matters, and that's gravity. And so the ball is in what we call free fall. And one of the components of free fall is this. It produces a constant acceleration. It's negative 9.8 meters per second squared. So it's always directed down and it has a constant magnitude. And since the acceleration is negative and constant, what that means is this. A graph of velocity versus time will always have a negative slope. So the graph will be a straight line with a negative slope, starts out positive, ends up negative. And the acceleration is the same whether the ball is moving up or whether the ball is moving down. Now something else which we'll learn about free fall is this. The acceleration is the same whether an object is moving up or whether it's moving down, but it's also the same acceleration for two objects of different sizes. If I drop these two objects at the same time, they hit the table at the same time. They have the same acceleration when they're in the air, that is, when they're in free fall. Now that is a somewhat counterintuitive notion because we're used to working with objects for which gravity isn't the only force that applies. So if I have this juggling scarf and I have a ball and I drop both of those, the ball hits the table first. But that's because there's a very, very different force which is at work. The different force that's at work is air resistance. But indeed, if we could go someplace where there was no air resistance, I could drop any two objects and they would fall only under the influence of gravity. The acceleration would be the free fall acceleration, and then hit the ground at the same time. Well, as a matter of fact, there are places where there is no air resistance. There are places where there's no air. And we'll look at an example right now. This is a video clip that was taken from when Apollo astronauts visited the moon. And one of the classic experiments which they recreated was this. One of the astronauts dropped a hammer and a feather on the moon. And the result is sort of surprising.
And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?